Hi guys, welcome to my channel. In this video, I will be covering what is MAC sublayer protocol and I will explain various types of MAC protocols. I will explain what are random access protocols, controlled access protocols and channelization protocols. I will explain each and every type in detail. Guys, we also call MAC protocols as multiple access protocols and MAC stands for medium access control. Guys, in exam you may get separate questions like explain CSMA, explain CSMA CA, what is token passing, what is CDMA, etc. So you need to be perfect on each and every protocol. Guys, whatever the protocols I am going to explain in this video, I will provide all those timings in description. So before starting this video, please check in description. Guys, I have uploaded complete computer network subject tutorials. I will provide that link in description. You can watch from there. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. Let's get started. At first, I will explain what is MAC sublayer protocol. Before explaining what is MAC sublayer protocol, at first you need to know what is shared medium or shared communication channel or shared network. For example, there are multiple computers which are connected to a single cable in order to transfer data. As all computers are connected to a single cable, we call this single cable as shared medium or shared communication channel or shared network because all computers are sharing single cable. Yes, for example, there are multiple devices which are connected to single wireless frequency for communication. As all devices are connected to single wireless frequency for communication, we call this single wireless frequency as shared medium or shared communication channel or shared network. So the shared medium, shared communication channel and shared network, they are nothing but single cable or single wireless frequency. OSI model contains 7 layers. On that second layer is data link layer and this MAC layer is sublayer of data link layer. And by using MAC sublayer, multiple devices can communicate each other using a shared medium without any interference. Shared medium is nothing but single cable where all devices are connected to this cable for communication. For example, there are multiple computers connected to a shared network like single cable and both computers will send data at the same time. If both computers send the data at the same time, then collision will occur. Collision is nothing but interference. Whenever two computers send data at the same time, collision will occur and data will be lost. So this data will be lost and this data will be lost and both computers will not receive data. So in shared network, whenever multiple computers send data at the same time, collision will occur. So this MAC sublayer will allow only one computer to send data at the same time. MAC sublayer will not allow multiple devices to send data at the same time. So MAC sublayer will allow only single device to send data at the same time. Guys, sometimes collision may occur. Whenever collision occur, computers need to resend data at random time. I will explain what is random time. Guys, for example, this computer will send data at 10 o'clock exactly and this computer also will send data at 10 o'clock exactly. So as two computers are sending data at the same time, collision will occur and data will be lost. As data is lost, computers need to send data again. For example, these computers will again send data at fixed time, like at exactly 10 o'clock 1 second, this computer will send data. And similarly, at 10 o'clock 1 second, this computer will send data. As both computers are sending data again at fixed time, that is 10 o'clock 1 second, again two computers are sending data at the same time, again collision will occur. That is why if collision occurs, computers need to send data at random time, not fixed time. If they send at fixed time, again collision will occur. So random time is nothing but this computer will send data at 10.1 second, this computer will send data at 10.4 seconds. They are sending data at random time, not at fixed time. So collision will not occur. So whenever collision occurs, computers need to send data again at random time. MAC, that is medium access control, is a sublayer of data link layer in the OSI model. It controls how multiple devices share a common communication channel without interference. Communication channel is nothing but single cable. When many devices try to send data at the same time on a shared network, collision can occur. Collision means data interference. So MAC sublayer will ensure that only one device can send data at the same time. So it will avoid collision. When two devices send data at the same time, due to their signal interference, collision will occur. This collision will damage data and receiver cannot receive data due to data loss. Whenever collision occurs, data will be lost. Sender will identify collision and retransmits the data after a short delay. After short time, again sender will send data. If two computers send data at the same time on a shared network, collision will occur. When collision happens, both computers will stop sending data and they will wait for some random time before trying again. Sending data at random time is done by CSMA CD protocol. And MAC sublayer protocols are classified into three types. Guys, we also call MAC protocols as multiple access protocols. Multiple access protocols are classified into three types. They are random access protocols, controlled access protocols, and channelization protocols. At first, I will explain what are random access protocols. Guys, random access protocols are classified into four types. They are Aloha, CSMA protocol, CSMA CD protocol, and CSMA CA protocol. At first, I will explain what are random access protocols. Random access protocols in computer networks are methods used to manage how multiple devices share the same communication channel, like a single wire or wireless frequency, to send data. Guys, in random access protocols, multiple devices are connected to single communication channel in order to send data. Guys, in random access protocols, devices can send data at any time, whenever they want. But if two devices send data at the same time, collision will occur. And if collision occurs, devices need to again resend data at random time. Random time in different time. Random access protocols are classified into four types. They are Aloha, CSMA, CSMA CD, and CSMA CA. I will explain each of them in detail. At first, I will explain what is Aloha protocol. Aloha is a random access protocol. In Aloha protocol, any device can send data at any time. There is no rule that device need to transfer data only at particular time. So any device can send data at any time in Aloha protocol. This actually Aloha was used in wireless LANs in order to connect to different places using wireless technology. But this Aloha is also used in shared medium where all devices are connected to a single cable. As I already said, in Aloha protocol, multiple devices can send data at any time. So if multiple devices send data at the same time, collision will occur. If collision occurs, data will be lost. So again, devices need to resend data after waiting for a random time. Guys, for example, there is device 1 and device 2. Both are connected by using a shared medium like a single wire, and both devices are transferring frames at the same time. Guys, frames are nothing but data. Instead of sending our data directly, we will place our data in frame and we will send data. So don't get confused. Frame is nothing but data. We will place our data in frame and we will send that frame. If two devices send frames at the same time, collision will occur. So again, devices need to resend data after a random time. Random is nothing but different time. One device will send data at one time and other device will send data at other time. So random time in different times. Thus, Aloha protocols are classified into two types. They are pure Aloha and slotted Aloha. At first, I will explain what is pure Aloha. Guys, in pure Aloha, without following any time period, device can send data at any time and device will not check whether channel is free or not. Channel is nothing but cable. Device will not check whether cable is free or not. Directly they will send data at any time. And if collision occurs, device need to resend data at different times. That is nothing but random times. As for example, there are 4 devices which are connected to a single cable. These lines are nothing but they are single cable. As I already said before, in pure Aloha, any device can send data at any time. For example, this is particular time period. In this particular time period, only device 1 is sending data. As no other devices are sending in this time period, receiver will receive this frame. And similarly, this is second time period. If you observe this time period, in this time period, device 1 is sending one frame, device 2 is sending one frame, device 3 and device 4. All are sending various frames. In this particular time slot, as all devices are sending data at the same time, collision will occur and all these frames will be lost. So as all these frames will be lost, receiver will not receive all these frames. In this particular time slot, device 2 is sending one frame and device 4 is sending one frame. As both devices are sending data at the same time, again collision will occur. These 2 frames will be lost. So again device need to retransmit these frames. In this particular time slot, only one device is sending data in this cable. So this frame is successfully reached to receiver. If collision occurs, all devices need to retransmit all these frames at random time. Random time is nothing but different time. For example, this computer will transfer frame at 10.1 second. This computer will transfer frame at 10.5 seconds, and this frame will be transferred at 10.10 seconds, and this frame will be transferred at 10 o'clock 12 seconds. Like that, each frame will resend data at random times. This is all about pure Aloha. Next, I will explain what is slotted Aloha. Guys, if you consider pure Aloha, in pure Aloha, any device can send data at any time. So there is high chance for collisions. In order to overcome problem of pure Aloha, slotted Aloha was introduced. In pure Aloha, any device can send data at any time. But whereas in slotted Aloha, device cannot send data at any time. In slotted Aloha, data sending time is divided into fixed time slots. As for example, there are 3 devices which are connected to a single cable. These lines are nothing but all are considered as single cable. So this is one single cable. In this single cable, data sending time is divided into fixed time slots. Yes, for example, let us say time is 10 o'clock and here time is 10.5 seconds, and similarly here time is 10 o'clock 10 seconds. Like that, sending time is divided into fixed time slots, and device can send data only at beginning of time slot. Device cannot send data at middle of time slot. Device need to send data only at beginning of time slot. Yes, for example, device 1 is sending one frame. As no other devices are transferring data in this time slot, frame 1 is successfully reached to receiver. Yes, for example, at 10.2 seconds, this device 2 want to send data, but device 2 cannot send data because in slotted Aloha, only at beginning of time slot, device need to send data. Then device need to wait for second time slot. Then device need to send data at second time slot, only in the beginning. That's for example, if you consider this time slot, in this time slot, both device 1 and device 3, both are sending frames at a time. As both computers are sending frames at a time, collision will occur. So this frame will be lost and this frame will be lost. So again, after waiting some random time, again device need to resend data. So even in slotted Aloha, collision will occur. As for example, if you consider pure Aloha, for example, let us say time is 10 o'clock. Here second slot begins at 10.5 seconds and here 10.10 seconds. If you observe here, device can send data at any time. They are not following any particular time slot. Like there is no rule that device need to send data only at beginning of time slot. So collision chances are very high. And even in slotted Aloha, collisions will occur. But when compared to pure Aloha, collision chances are very less because data will be transferred only at beginning of time slot. If a computer miss allotted time, it must wait for next time slot. This reduces the chances of collision. But if two devices send data at the beginning of the time slot, again collision will occur. So again two devices need to wait for random time, and again they need to resend data at next available time slots. This computer will send data at one time slot, and similarly this computer will send data at other time slot. Next I will explain what is CSMA protocol. The CSMA stands for Carrier Sense Multiple Access. Name itself says carrier sense. Thus carrier is nothing but single cable. As all devices are connected to single cable, if any device want to send data, at first it will sense carrier. That is, it will check whether any other device is sending data or not. If no device is sending data, then this device will send data. So in carrier sense multiple access, before sending data, at first device will sense carrier. If carrier is free, device will send data. If carrier is busy, device will wait for some random time and it will send data. So before sending data, if device sends carrier, it will reduce collisions. Thus still in carrier sense multiple access, collisions will occur. For example, this computer want to send data, so at first it will sense carrier, whether channel is free or not. This computer also want to send data, then this computer also will check whether channel is free or not. If two computers sense channel at the same time, collision will occur. This computer and this computer both will sense channel at the same time, and they both will identify that no other device is sending data. And now two computers will send data at the same time in the single channel. As two computers are sending data at the same time, collision will occur. So in carrier sense multiple access, if two devices sense the channel at the same time, then collision will occur. CSMA is a random access protocol used in computer networks to manage how multiple devices share a single communication channel. In CSMA, multiple devices will share single communication channel. Carrier sense mean before sending data, at first device will sense carrier. That is, device will check whether communication channel is free or not. If channel is free, device will send data, and if channel is busy, device will wait for some time and then it will try again. So if device sends channel before sending data, it will reduce collisions. In CSMA protocol, still collisions will occur because of propagation delay. I will explain what is propagation delay. For example, two devices want to send data at the same time. So two devices will check channel at the same time. As two devices are checking channel at the same time, they will identify that channel is free. As channel is free, two devices will send data at the same time. So collision will occur. This is meaning of propagation delay. Guys, CSMA protocols are classified into three types. They are non-persistent CSMA, one-persistent CSMA, and p-persistent CSMA. In non-persistent CSMA, at first device will sense channel and it will identify that in this particular time, some other device is sending data. So channel is busy. So in non-persistent CSMA, at first device will sense a channel and it will identify that channel is busy. So it will wait for some time and again device will sense a channel and still channel is busy. So again device will wait some time and again device will sense a channel. This time channel is not busy. This time channel is free. So as channel is free, this device will send data. Yes, actually in this time period, channel is free. But in non-persistent CSMA, device will wait some time and it will sense channel. That is why time will be wasted. And whereas if you consider one persistent CSMA, in one persistent CSMA, if channel is busy, device will continuously sense channel until channel is free. So here channel is free, device will immediately send data. This is one persistent. In non-persistent, if channel is busy, device will wait some time and then it will sense channel. And whereas in one persistent CSMA, if channel is busy, device will keep on sensing channel continuously. And if channel is free, immediately device will send data. Here time will be wasted. And whereas one persistent CSMA will save time. And next one is p-persistent CSMA, where p stands for probability. Thus even in p-persistent CSMA, device will continuously keep on sensing channel until channel is free. And if channel is free, device will not send data directly. At first device will wait some time in order to sense whether any other device want to send data in this time slot or not. If no device want to send data in this time slot, then this device will send data. As for example, in this time slot, probability is less. That means other device want to transfer data in this time slot. So this device will not send data. Similarly, in this time slot, probability is low. That means other device want to use time slot. So this device will not send data. And similarly, here also probability is low. Other device want to use this time slot. So this device will not send data. And at last in this time slot, probability is high. That is, no other device are sending data in this time slot. So this computer will send data in this time slot. This is all about p-persistent CSMA. So CSMA protocols are classified into three types. They are non-persistent, one-persistent, and p-persistent CSMA. In non-persistent CSMA, device will check whether channel is free or not. If channel is busy, device waits for a random time before checking again. If channel is free, device will send data immediately. As device is waiting some time before trying again, it will reduce collisions. Device will not keep on checking continuously whether channel is free or not. So non-persistent CSMA is slow. And whereas in one persistent CSMA, device will keep on checking channel continuously until channel is free. And if channel is free, device will transfer data immediately. So one persistent CSMA is fast. Just for example, this computer want to send data and similarly this computer want to send data. Other devices are using this channel. So both devices will keep on continuously checking and immediately when channel is free, immediately both devices will send data. So again collision will occur because after continuously sensing, both devices will send data at the same time. So here collision chances are very high. And whereas in p-persistent CSMA, a device check if channel is free or not. If channel is free, it send data with a probability. If not, it will wait for next time slot and try again. That's where p stands for probability. If probability is less, that means other device may use the channel, so device will not send data. And if probability is high, that means no other device will use this time slot, so this device will send data in this time slot. Next I will explain what is CSMA CD protocol, where CSMA stands for carrier sense multiple axis and CD stands for collision detection. Guys, we'll use CSMA CD protocol in wide networks like Ethernet cables. In CSMA CD protocol, if any device want to send data in communication channel, at first device will listen to the channel. Listening is nothing but device will check whether channel is free or not. If channel is free, then device will send data, and if channel is busy, then device will wait some time and again it will send data. And if multiple devices send data at the same time, then collision will occur. In CSMA CD protocol, whenever collision occurs, device will identify collision and device will immediately stop transmission. So in CSMA CD protocol, whenever collision occurs, device will immediately stop transmission. If we stop transmission immediately, then it will save our time. If collision occurs, device will not send data immediately. Instead, before retrying, device will wait for some random time. We call this random time as back of time. After waiting for some random time, device will again send the data. Yes, for example, this is communication channel, that is nothing but single wire. One device is sending one frame at a time. As device is sending frame, we call it as transmission period. After sending frame, device will not send other frame immediately. It will wait some time before sending other frame. As device is waiting some time in order to check whether collision will occur or not. This time is known as contention period. So contention period is nothing but minimum waiting time that particular device will follow in order to check whether collision will occur or not. This is contention period. As no collision will occur, device will send other frame. Just for example, there are multiple devices which want to send data at the same time. So before sending data, all devices will wait. As all devices are waiting at the same time and they are not sending data, in this particular time period, there will not be any data transfer. We call this time period as ideal period. So as there is ideal period, again device will wait some time in order to check whether collisions will occur or not. We call the time period as contention period. After contention period, device will send data. This is all about CSMA CD protocol. Next I will explain what is CSMA CA protocol, where CSMA stands for carrier sense multiple axis and CA stands for collision avoidance, where in this protocol collision occurrence is very rare, and we will use CSMA CA protocol in wireless networks like Wi-Fi. In CSMA CA protocol, device will listen to the channel before sending data. If channel is free, it will not send data immediately. Instead, device will send one small request to receiver. We call that request as request to send signal. If receiver is ready, then receiver will give one signal. We call that signal as clear to send signal. Once if sender gets CTS signal, then sender will send actual data. As for example, there is sender and there is receiver. Sender will identify that no other device is using this channel, so channel is free. And the sender, before sending actual data, at first sender will give one signal to receiver in order to send data. We call that signal as RTS signal, where RTS stands for request to send signal. So receiver will take the signal, then receiver will give other signal to sender. We call that signal as clear to send signal. Shortly we call it as CTS. So whenever sender gets CTS signal, sender will now send actual data. If data is successfully received to receiver, then receiver will give acknowledgement. That is nothing but receiver will give reply like data is reached successfully. Maximum collisions will not occur in CSMA CA protocol. But whenever collision occurs, computers need to wait for some time and again they need to send request to send signals. This is all about CSMA CA protocol. Next I will explain what are controlled access protocols. Guys, controlled access protocols will allow only one device to send data at a time. So it will prevent collisions. And in controlled access protocols, whenever any device want to send data, at first the device must get permission. Only if device get permission, the device can send data. As device need to get permission before sending data, controlled access protocols will ensure efficient data transfer. Guys, whereas if you consider random access protocols, in random access protocols, any device can send data at any time without waiting for permission. And whereas in controlled access protocols, device must get permission in order to send data and only one device will send data at a time. So there will not be any collisions. Controlled access protocols are classified into three types. They are reservation protocol, polling protocol and token passing protocol. At first I will explain what is reservation protocol. Name itself says reservation protocol. If any device want to send data, at first device must reserve time slot. After device reserving particular time slot, only in the time slot device can send data. Just for example, I want to travel other place in train. So at first what I will do is, I will do one seat reservation. After doing reservation in that particular time period, I can travel in train. Even though if I travel or don't travel, that seat will be reserved. In same way, even in reservation protocol, at first device must reserve a time slot in that particular communication channel in order to transfer data. That this is structure. Guys, for example, all time slots are empty. For example, this device 1 reserved this time slot. So in this particular time slot, this device can send data. As already first slot is reserved by device 1, no other device can use this slot. Similarly, now device 2 and device 3 both will reserve slot 3 and slot 4. So in this particular time slots, this device can send data. Guys, there will be one central system. The device will give each time slot to each device. These are advantages of reservation protocol. As each device will get particular time slot, there will not be any collisions. Guys, reservation protocol is used in satellite communications. And these are disadvantages. And the first one is, guys, for example, device 1 took this time slot, but device 1 is not sending data. So this time slot will be wasted. And in order to give reservations for each device, there must be one central system. So if central system fails, device will not get time slots and device cannot communicate. This is all about reservation protocol. Next I will explain what is polling protocol. As for example, if you want to vote, we will go to polling booth. In polling booth, there will be one employee. He will call each person in order to vote. Even in polling protocol, there will be one central device. This central device will call to each device in order to send data. Once if device 1 send data, the system will call to device 2. Again device 2 will send data. So central computer will call each device in circular manner. If device don't want to send data, then the central system will call to other device. These are advantages of polling protocol. A server will call each device one by one. There will not be any collisions. And next advantage is server will give chance for each device in order to send data. And these are disadvantages. A server calling each device one by one. So polling protocol is slow. And if central system fails, device cannot send data. And third one is token passing protocol. First device will get one token. So whenever device get token, this device can send data to other device. After this device successfully sending data, this token is given to device 2. Device 2 will send data. Similarly, token is given to device 3, device 4 and so on. So token is passed in circular manner. Whenever device get token, at that time device can send data. If device don't want to send data, then token is moved to other device. These are advantages. As only one device can send data by using token, collisions will not occur. Thus, token passing protocol is suitable for computers which are connected in circular manner. Once if any device lost token, communication stops until new token is generated. So device need to wait long time in order to get new token. Next I will explain what are channelization protocols. Guys, we will use channelization protocols mainly in wireless communications. In channelization protocols, we will divide our entire communication channel into smaller channels. After dividing entire channel into separate smaller channels, we will give each separate channel to each user. So by using the smaller channels, users can communicate. As each and every user will get separate channels, all users can send data at the same time. So there will not be any interference. Guys, bandwidth is nothing but how much amount of data that can be traveled per second in communication channel. So in channelization protocols, all users can send data at the same time. So lot of data will be traveled in network at the same time. So there will not be any bandwidth wastage. Even though multiple users send data at the same time, collision will not occur. The channelization protocols will use multiplexing. Multiplexing means in single communication channel, as each user will get one separate small channel, multiple users can send multiple signals at the same time. This is meaning of multiplexing. The channelization protocols are classified into three types. And the first one is frequency division multiple access. Name itself says frequency division. That is nothing but entire frequency is divided into smaller frequencies and each user will get one frequency. By using that small frequency, users can communicate. As for example, there is one big wireless frequency band. For example, this frequency will support data speed that is 1000 GB per second. But if you assign this entire frequency to single user, a single user don't get this much frequency. So entire frequency will be wasted. So in frequency division multiple access, our entire communication channel is divided into smaller channels and each channel will get one small frequency. By using that small frequency, device can communicate. So in frequency division multiple access, we will divide our transmission medium into smaller frequency bands and each user will get one frequency band. By using that frequency band, users can communicate. As each user will get one frequency band, all users can communicate at the same time. So even though all users send data at the same time, there will not be any interference. Collision will not occur. As for example, This is communication channel. We will divide our communication channel into smaller channels and each user will get one channel. By using that channel, user can communicate. Because for each and every channel, we need to leave small gap. If we leave small gap, two channels will not interfere. That is why we need to give small gap between each and every channel. We call this gap as guard band. Because for example, this is entire frequency that communication channel will support. This entire frequency is divided into smaller channels. Each user will get one frequency. As each device will get one frequency, by using that frequency, device can communicate. These are characteristics of frequency division multiple access. And the first one is frequency allocation. As I already said before, each user will get one frequency band. By using that band, users can communicate. And second one is continuous transmission. Guys, all devices can transfer data at the same time. So there is no need of waiting for time slot. All users can send data at any time. So there will be continuous data transfer. And third one is guard band. For each and every channel, we need to leave small gap. We call that small gap as guard band. If we leave small gap, channels will not interfere. All channels can communicate smoothly. And these are applications. We used FDMA in 1G mobile communications. And we also used FDMA in FM radio stations. These are advantages. First one is simplicity. FDMA is easy to implement. And next one is low latency. As each user has separate frequency band, data can be transferred without waiting for time slot. So there will not be any latent data transfer. These are disadvantages. And the first one is, as each user get one separate frequency, if user don't use that frequency band, then that frequency band is wasted. If users increases, then managing frequency bands are very tough. Next I will explain what is time division multiple access. Name itself says time division. Instead of dividing entire frequency, here we will divide our entire communication channel into time slots. And each user will get one time slot. And that particular time slot, user can communicate. These are characteristics of TDMA. And the first one is time slot allocation. I already said before, each device will get one time slot. And that particular time slot, device can communicate. And second one is synchronization. Yes, synchronization means each device must know at what time slot will begin and at what time slot ends. So device can use only that particular time slot or else collision will occur. These are applications of TDMA. We will use TDMA in 2G networks and also in satellite communications. This is structure of TDMA. We will divide our entire frequency into time slots. So each user will get one time slot. On that particular time slot, user can communicate. These are advantages of TDMA. And the first one is efficient bandwidth usage. As each and every user will get one time slot, all users will use time slots without wasting. And also, multiple users can send data at different time slots without interference. As channel is divided into time slots, there will not be any interference. As device will use only particular time period in order to send data, power charges will be low. These are disadvantages. And the first one is communication delays. As user need to wait for time slot for communication, so there will be communication delay. Because for each and every time slot, we will leave some time in order to avoid collision, and we call the time as guard time. So some time will be wasted for communication. And next disadvantage is each and every user must follow particular time slot. If they don't follow particular time slot, collision will occur. And last one is code division multiple access. Name itself says code division. Guys, in code division multiple access, all devices will send data at the same time. Even though all devices send data at the same time, there will not be any collision because along with data, each user will add separate code. Based on this code, data will be transferred to correct receiver. So in CDMA, one channel carries all transmissions simultaneously. Simultaneously means all devices can send data at the same time. This is all about CDMA, that is code division multiple access.